The evening of August 21st, 1986, settled over the lush valleys of northwestern Cameroon like any other. In the village of Nyos, families gathered for their evening meals. Children played in the dusty streets while their parents tended to livestock and prepared for the night ahead. The air was thick with the familiar sounds of rural African life. Chickens clucking, dogs barking, the distant lowing of cattle settling down for the evening. About 9 miles away, Lake Nyos sat in its volcanic crater, a beautiful deep blue body of water that the locals had lived beside for generations. It was a place of such tranquility that no one could have imagined it was about to become the site of one of the most unusual natural disasters in recorded history. As darkness fell, something began to stir beneath the surface of Lake Nyos. The lake, which filled a roughly circular volcanic crater about a mile wide and nearly 700 feet deep in places, had been accumulating a deadly secret for perhaps hundreds of years. Deep beneath its waters, in pockets and fissures in the volcanic rock, carbon dioxide had been slowly seeping upward from the magma chamber below. The immense pressure at the bottom of the lake had allowed the water to dissolve far more CO2 than would normally be possible, much like how a sealed bottle of soda holds carbonation under pressure. The lake had become oversaturated, a liquid time bomb waiting for something to trigger its release. What exactly caused the eruption that night remains a subject of scientific debate to this day. Perhaps it was a small landslide on the crater wall, or maybe cold rain hitting the warm surface water created circulation currents. Some scientists believe a small volcanic disturbance might have been the catalyst. Whatever the trigger, sometime around 9:30 that evening, the bottom waters of Lake Nyos suddenly began to release their dissolved carbon dioxide in a process called a limnic eruption. The release was catastrophic and almost instantaneous. As the first bubbles of CO2 rose from the depths, they caused more CO2 to come out of solution, which in turn triggered more release in a violent chain reaction. Within moments, an estimated 100 million to 300 million cubic meters of carbon dioxide exploded from the lake surface in a massive, silent eruption. The force was so powerful that it created a fountain of water and foam that some scientists estimate reached heights of 300 feet. The eruption was so violent that it created waves that stripped vegetation from the shores up to 80 feet above the normal waterline. But the truly terrifying part of this disaster was what happened next. Carbon dioxide is heavier than air. Instead of dissipating harmlessly into the atmosphere, the massive cloud of gas began to flow down the valleys surrounding the lake like an invisible river of death. Moving at speeds estimated at nearly 60 miles per hour in some places, the CO2 cloud hugged the ground, displacing the oxygen as it traveled. The gas was cold from the deep lake waters, which made it even denser and more likely to stay low to the ground. It was completely odorless and invisible, though many survivors later reported smelling something unusual, possibly the smell of gunpowder or rotten eggs from other volcanic gases mixed with the CO2, or perhaps the smell of vegetation being killed by oxygen deprivation. The cloud traveled down two main valleys from the lake, engulfing the villages of Nyos, Kam, and Cha. In the darkness, no one saw it coming. There was no warning, no alarm, no time to react. The people of these villages were simply going about their evening routines when death arrived on a silent wind. What happened in those villages over the next few hours was something from a nightmare. As the carbon dioxide concentration in the air rose above 10%, people began to lose consciousness within minutes. At concentrations above 30%, unconsciousness was almost immediate. The gas essentially suffocated its victims, replacing the oxygen they needed to breathe. Most people never woke up. They died in their sleep, peacefully perhaps, but no less tragically for it. Some people who were still awake reported feeling suddenly weak and dizzy before collapsing. A few fortunate individuals at higher elevations or in areas the cloud didn't fully penetrate managed to survive, though many lost consciousness for hours. When dawn broke on August 22, 1986, the scene that greeted survivors was utterly surreal. Joseph Nquine, a survivor from the village of Subum, later described waking to find his family dead around him. He had been at his daughter's house when he heard a strange noise and smelled an unusual odor. He felt weak and collapsed, only regaining consciousness after 6 hours to discover his daughter dead beside him. Walking through his village, he found everyone lying motionless, humans and animals alike, as if some invisible force had simply switched off their lives all at once. The death toll was staggering. In the village of Nyos, which sat closest to the lake, nearly everyone died, over 1,200 people. In Kham and Cha, hundreds more perished. The final death count reached 1,746 people, though some estimates suggest it could have been even higher. More than 3,500 cattle, countless dogs, chickens, wild animals, and even insects were found dead. The landscape was littered with corpses in positions that suggested instant death. People lying in their beds, sitting at tables, or collapsed where they had been walking. Survivors who had been at higher elevations or further from the lake's deadly cloud began to discover the catastrophe as the morning progressed. They found their friends and families dead, with no visible injuries, no signs of violence, no explanation for what had killed them. The cattle in the fields were dead. Birds had fallen from the sky. The villages were utterly silent except for the buzzing of flies that had already begun to gather. Many survivors, traumatized and confused, simply fled, not knowing what invisible killer might still lurk in their homes. When news of the disaster finally reached Cameroonian officials and then the international community, the response was swift but equally confused. Early reports were fragmentary and contradictory. Some speculated about chemical warfare or poison gas attacks. Others wondered if a volcanic eruption had occurred. Medical teams who arrived to treat survivors found people with symptoms consistent with asphyxiation, but no one could initially explain what had caused such widespread deaths so suddenly. It was when scientific teams finally reached Lake Nyos itself that the first real clue emerged. The lake, which had always been a clear, beautiful blue, had turned a strange reddish-brown color. The water looked murky and disturbed, and there was a strong smell of sulfur in the air. Dead vegetation floated on the surface, stripped from the shoreline. The water level had dropped by about 3 feet, and there were marks on the shore showing where waves had washed much higher than normal. Something massive had happened at the lake. But what? Scientists from Cameroon, France, and the United States began to investigate. They collected water samples from different depths in the lake and analyzed the gas composition of the surrounding air. What they discovered was both fascinating and terrifying. The lake water was severely depleted of carbon dioxide compared to measurements taken before the disaster. The bottom waters showed clear signs of having been mixed with surface waters, something that normally never happened in this stratified lake. Chemical analysis of the water and gas samples confirmed that a massive release of CO2 had occurred. As the investigation continued, scientists began to piece together the geological history that had led to this disaster. Lake Nyos sits in the crater of an extinct volcano that last erupted perhaps 400 years ago. However, beneath the lake, in the volcanic rock and deeper into the earth where magma chambers still exist, carbon dioxide continues to seep upward. This is not uncommon in volcanic regions around the world. What made Lake Nyos particularly dangerous was its depth and the unique chemistry of its waters. The lake is stratified, meaning the water at different depths doesn't mix. The bottom waters are slightly saltier and much colder than the surface, creating distinct layers. This stratification prevented the CO2 that was dissolving into the bottom waters from escaping to the surface naturally. Year after year, century after century, more and more CO2 accumulated in the deep waters. Scientists calculated that the lake could have been accumulating carbon dioxide for hundreds of years before the 1986 eruption. Think of it like a bottle of champagne that's been shaken but not yet opened. The pressure keeps the carbon dioxide dissolved in the liquid, but the moment you release that pressure, by opening the bottle, all that gas comes rushing out in an explosive release. Lake Nyos was a champagne bottle on a massive scale, and something finally popped the cork. The investigation revealed something even more disturbing. This could happen again. Not only could Lake Nyos experience another limnic eruption if carbon dioxide continued to accumulate in its depths, but there were other lakes in the world with similar geological characteristics. Scientists identified Lake Manoon, just 60 miles away from Lake Nyos, which had experienced a smaller but similar eruption in 1984 that killed 37 people. That event had been written off as a localized incident, but now it was clear that these lakes represented a previously unrecognized category of natural hazard. The international scientific community began searching for other potentially dangerous lakes. They found them in several volcanic regions around the world, though thankfully only a few appeared to pose immediate danger. The Democratic Republic of Congo has Lake Kivu, which sits on the border with Rwanda. Lake Kivu is enormous, more than 1,600 square miles in surface area, and contains an estimated 300 cubic kilometers of dissolved carbon dioxide and methane. More than 2 million people live in the basin surrounding Lake Kivu. If it experienced a limnic eruption, the catastrophe would be almost unimaginable in scale. The discovery of these dangerous lakes pose an urgent question. What could be done to prevent future disasters? The solution that scientists developed sounds almost comically simple, yet it's based on solid scientific principles. They needed to degaz the lake, to remove the excess carbon dioxide in a controlled manner before it could erupt naturally. The technique they pioneered is often called the straw method because it works much like using a straw to release carbonation from a soda. A long pipe is placed vertically in the lake, extending from the surface down to the deep CO2-saturated water at the bottom. Initially, water from the bottom must be pumped up through the pipe to get the process started. But once that gas-rich water rises above a certain depth, the decreasing pressure causes the dissolved CO2 to come out of solution and form bubbles. These bubbles make the water in the pipe less dense, which causes more deep water to flow up into the pipe, which releases more CO2, which creates more bubbles in a self-sustaining reaction. Eventually, the pipe creates a fountain of water and gas at the surface that operates continuously, powered only by the pressure difference in the gas itself. The first degassing pipe was installed at Lake Nyos in 2001, 15 years after the disaster. It was a French-funded project, and watching it operate was both impressive and eerie. Water and gas erupted from the surface in a continuous fountain, visible from miles away. The fountain released carbon dioxide safely into the atmosphere, where it dispersed harmlessly, slowly reducing the concentration of dissolved gas in the lake's depths. Initial measurements showed the system was working. The CO2 levels in the bottom waters began to decline. But one pipe wasn't enough for a lake the size of Nyos. Scientists calculated that multiple pipes would be needed to fully protect the surrounding communities. Additional pipes were installed in 2011, funded by international aid. Today, there are 5 degassing pipes operating at Lake Nyos, continuously releasing the accumulated carbon dioxide and preventing another lethal buildup. Similar systems have been installed at Lake Manoon, and there are plans to implement degassing at Lake Kivu, though the scale of that project is considerably more complex. The degassing solution has proven effective, but it requires constant monitoring and maintenance. The pipes must be kept clear, and the flow rates must be measured to ensure they're removing CO2 faster than it accumulates. Scientists regularly sample the lake waters at various depths to track the concentration of dissolved gases. Teams of experts return periodically to check the equipment and verify that the lakes remain safe. The communities affected by the 1986 disaster have slowly rebuilt. Survivors gradually return to their villages, though Lake Nyos itself remains largely uninhabited, with the settlement relocated to safer ground further from the water. The lake has returned to its normal blue color, and on the surface it looks peaceful once again. But the fountains from the degassing pipes serve as a constant reminder of the invisible danger that once lurked beneath those calm waters. The Lake Nyos disaster taught scientists several crucial lessons about natural hazards. First, it revealed an entirely new type of disaster that no one had predicted or prepared for. Limnic eruptions had probably occurred before in Earth's history, but never in recorded human experience with such devastating results. The disaster highlighted how much we still have to learn about the planet we live on and the sometimes unexpected ways that geological processes can threaten human life. Second, it demonstrated the importance of understanding the geological context of human settlements. The villages around Lake Nyos had existed for generations with no awareness of the danger literally brewing beneath the lake's surface. Better geological surveys and hazard assessment in volcanic regions could help identify other potentially dangerous locations before tragedy strikes. Third, the successful development of the degassing technology showed that even with natural disasters, human ingenuity can devise solutions to protect vulnerable populations. The degassing pipes at Lake Nyos represent a triumph of applied science, a simple, elegant solution to a complex and deadly problem. Today, scientists continue to monitor the dangerous lakes of the world. At Lake Kivu, various proposals have been made not just to degaz the lake for safety, but to potentially harvest the methane dissolved in its waters as an energy source, which would have the dual benefit of producing power while reducing the danger. Research continues into better methods for detecting lakes that might pose similar risks, using satellite imagery and geochemical surveys to identify crater lakes in volcanic regions that might be accumulating dangerous levels of dissolved gases. The story of Lake Nyos is ultimately one of horror and hope intertwined. The disaster itself was terrifying, an invisible killer that struck without warning, leaving entire villages dead in their sleep. But it's also a story of how science can take even the most mysterious and frightening natural phenomena and not only explain them, but find ways to prevent future tragedies. The villages around Lake Nyos no longer live in fear of the lake that once killed so many of their people. The fountains continue to spray, the CO2 levels continue to drop, and the survivors and their descendants can rest easier, knowing that science has essentially diffused a natural time bomb that had been ticking beneath their feet for centuries. The disaster remains a sobering reminder that our planet still holds dangers we're only beginning to understand, and that nature's most deadly threats aren't always the ones we can see coming.